Hello, and welcome to today's WTA webinar, the DVB NIP Revolution. My name is Randall Barney. I'm the Executive Director for the World Teleport Association. WTA every day is an advocate for the interests of teleport operators as well as the promotion of the excellence in their operations, their technology, and their business practices. Our webinar today is based on a report that is available on our website of the same title, and we'll be talking about that in just a moment. WTA's research reports are guided by WTA's Technology Advisory Board. The Technology Advisory Board was formed to address the rising challenges and opportunities that our leading members. What are their most important advances you need to keep an eye on, and what are some of the appropriate technologies for the kind of needs you have? Membership of the Advisory Board is open to industry patron and leader members. If you want more information, please send an email to me, rbarney@worldteleport.org. Our Technology Advisory Board members are Comtech, Hughes Network Systems, Kratos Defense, Network Innovations Advanced Networks, and Nexat. Sponsors of this report are Eutelsat and ST Engineering iDirect. WTA research reports and webinars are also made possible by our industry leader members. They are Eutelsat, Intelsat, Kratos, and SES. The past decade has been challenging for satellite TV, with U.S. pay TV households dropping 31% from 84 million in 2019 to 58 million in 2023, in a report by Statista. While growth in Asia-Pacific and EMEA offset some losses, Ampere Analysis predicts that the first ever global decline in pay TV penetration. In response, the broadcast industry is evolving, with DVB NIP, DVB Native IP, emerging as a potential game changer. This standard enables over-the-top OTT content delivery via satellite or terrestrial broadcast, seamlessly integrating with IP networks. Published in 2024, DVB NIP is gaining industry momentum, with developers and early adopters seeing it as a bridge between traditional satellite broadcasting and modern streaming, expanding reach even in areas with limited terrestrial coverage. DVB is in a response to changes in the sector. Broadcasting is well into a massive shift from satellite to internet delivery. The majority of video traffic is now delivery via IP, streaming services, corporate media, social media, and e-learning. DVB NIP will help satellite services blend seamlessly with other IP networks and is a necessity to help the satellite broadcast sector remain a viable player in the market, as well as help solve challenges being created by ever-growing amount of video content being delivered to smart devices via the internet. The technology is already proven. There has been positive feedback regarding DVB NIP development efforts. Demonstrations at trade shows and a major deployment project with the government of Peru have shown that DVB NIP is ready to be deployed and make an impact for satellite broadcasters. Companies are ready to roll out the solutions. Companies that contributed to the development of DVB standard are ready to offer the solutions to media broadcasters. Many consider rollout of the technology and the needed equipment to be a simple process. They are just waiting for customer demand. The business cases are still being developed. Service providers trust the DVB NIP standard and see its potential, but many are hesitant to move forward with a strong business justification. With end user customers seeking more and more short-term contracts, 1 or 2 years, to maximize their own flexibility, some service providers are not sure that the investments needed to offer DVB NIP services will provide the needed returns. Some use cases are already gaining traction, however, such as content distribution for distance learning, maritime, aeronautical connectivity, and multicasting for guests in the hospitality industries. DVB NIP brings satellite reach to streaming video services. One of the key advantages to satellite broadcast is the capacity to reach the user wherever they are in the coverage area. With DVB NIP, this capacity is accessible to video services based on IP delivery. DVB NIP puts satellite in a better position. The world is consuming more video outside of traditional TV streams, and the development of DVB NIP is a recognition that the satellite broadcast sector needs an IP delivery solution. Satellite remains the most efficient manner to deliver content at scale, and DVB NIP brings the advantages of modern IP-based clients together with the quality and efficiency of broadcast delivery. With DVB NIP, satellite will be able to work with IP networks and compete when the opportunity arises. I would like to welcome my panelists today. They are Rami Moussaoui, Senior Product Manager for ST Engineering iDirect, Laurent Lavelle, Head of Multi-Screen Services of Eutelsat Group, and Emily Dubbs, Head of Technology DVB Project. Welcome, guys. Real quickly, if you can please introduce yourself and tell us a little bit about how you relate to DVB in your respective field.
So hi, everyone, and thank you very much for this introduction and for the invitation, of course. So I'm head of technology for DVB since 2020, so a bit more than 5 years. And so I joined DVB at the time where DVB Native IP was actually trying to be specified by DVB. So because before joining DVB, I had roles at DVB members like Teamcast, which is NNC's now, so a modulation company. But more recently, before joining, I was involved in a product strategy in a company developing receivers that I tried to design for the delivery of OTT over broadcast networks. So this is, yes, how I was involved in, I would say, the DVB Native IP's predecessor.
Okay, great. Laurent?
Yeah, so I'm Laurent Lavelle. I'm part of Eutelsat Group. So, you know, Eutelsat Group, we have two main activities and two business units related to this activity, video and connectivity. And I'm part of the marketing and product development department within the video business unit. And part of my mission is the promotion and the transformation of the video services delivered over satellite broadcast and the definition of the services related to native IP technologies.
Very great. And Rami?
Hi, everyone. My name is Rami Moussaoui. I'm a Senior Product Manager here at ST Engineering iDirect, and I'm focused on our media and broadcast solutions. For those of you who aren't familiar with ST Engineering iDirect, we're a global leader in the satellite communications space with a focus on the ground segment portion as a technology provider and leader, and also a leader in the DTH and media and broadcast world. We've been involved in the broadcast space for over 30 years, and we've been active members of the DVB project, contributing to the project all the way since 1994, back with the DVB-S standard, and all the way through DVB NIP, which we contributed to the definition of the commercial and technical requirements for. So in principle, our vision as ST Engineering is to rapidly expand the accessibility of satellite communications worldwide, ensuring seamless, affordable connectivity to reach more people, industries, and geographies.
All right, great. And just a reminder, if you do have questions, please submit them through the Zoom chat, and we'll try to get to them through this panel. So first, Emily, can you give us a reminder of what DVB is?
Sure. So we are so a consortium led by media companies, even leading companies in the media industry, who actually decided to join forces to work on or to deliver the specifications that are needed for the markets. And as you've mentioned, Rami, it started so quite a long time ago, about more than 30 years now, around a very pressing need to define the right standards for transition from analog to digital, and the first one was about the satellites. So there has been a huge work from, so initially it was about 80 companies who joined forces, and I've been told that that specification was written in a very efficient manner because it was really a strong need in the market. So there's been several phases for DVB. So the reason for the creation was the global transition to digital TV, but then it was after that transition from SD to HD, and there's been more steps. But more recently, I would say the challenge for the industry is the migration from pure broadcast to broadband or even hybrid delivery networks. So this is our focus today, to help broadcasters with their migrations to those hybrid delivery networks. And DVB Native IP is indeed one of the, it's part of the IP-centric solutions that we have developed recently on this goal.
And staying with you, Emily, where does DVB Native IP come from?
So actually, that's it comes from, I would say, the preparation of the solution comes from much longer than, I mean, DVB. So I've told at the beginning, I was involved in a company trying to evangelize the idea of delivering OTT over broadcast. That was an idea actually that I could even say that's one of the ideas that comes from corridor discussions at trade shows. I remember exactly when, because I was in product strategy and innovation and discussing with some former colleagues. It was really enlightening sometime, and some pioneer in this area was Broadpeak, for instance, and they had that idea, which I found very interesting. So I worked so specifically in this area in which I believed, and it was about 10 years ago. So yeah, around 2016. And the demand, so the demand was really here. That's usually how a solution is built. There's a strong demand, then some companies are trying to develop the, to answer the need. And it was coming from different parts of the world, but mainly from emerging areas. So we had, for instance, Astro willing to offer a service of streaming, so streaming in their hotels with broadcast quality. So to give the ability to their customers to have access to live TV, but through broadcast, so without the struggle of the peak traffic when everyone is back at home at the same time or back at the hotel at the same time. So there was, there's been a development for that. There's been another one for a Russian operator who wanted to sell a similar service, but for restaurants. So there was a need. Actually, it was very difficult to promote and to roll out because it was relying on proprietary standards, proprietary solutions, sorry. It was coming from the collaboration of a few people only, a few companies, and that was not enough because the market does not want to be stuck in one with one vendor, and they want to have the choice. So that's why the standards are very important. So that was before coming to DVB. And when I joined DVB, actually, the topic was brought in DVB already. It was brought as an idea or so, but not, I mean, the real work was not yet started because it generated some lively debates. But then once approved, I mean, then the work was undertook in a very, very efficient manner, say mainly by two well-known satellite providers. I mean, the chairs of the group who developed the solution were coming from Eutelsat on one hand and ACS on the other hand. So
yeah, on our side at Eutelsat, we were part of this first initiative to develop this kind of solution as a proprietary solution, and we felt that to move this kind of solution forward, we needed to have a standard to bring interoperability and to have a wider ecosystem that working on this type of technology.
That's the right.
And that's why we contribute to that, and we thought it was an industry. It should be an industry initiative, and we formed this group with DVB and SES to move forward with standardization.
Yeah, and for iDirect, you know, standardization is core of our DNA. As I indicated before, we've actively been developing and participating in the support and definition of some of these requirements, working with the big players like Eutelsat and others to be part of the requirements and the definition of where we see our customers requiring this. We also had proprietary solutions that our customers were deploying on our VSAT systems and products, but it was important for us to be part of a standard because we truly believe that that's the proper way of delivering technology.
Hey, great. So Laurent, what challenges does DVB NIP help solve for satellite broadcasters in a world shifting toward IP-based streaming?
Yeah, said it. The shift is toward IP-based delivery. And in fact, most of the broadcasters, the content owners, they distribute their content through broadcast and through broadband. So they do both, in fact. And for that, the challenge on the broadcast part is really to bring a better user experience, because most of the content owners, when they are thinking of their user experience, they are thinking streaming first. And so with broadcast, they need to bring a better user experience, to bring a multi-screen. And also, one of the challenges that they face is they need to streamline their operation. Today, they deliver on both sides, and they have two separate systems to deliver the content on broadband and on broadcast. So that's where native IP helps, because it's help them to bring their operation down one single headend, one single backend to distribute their content on the two vectors, and they are able also on the broadcast side to bring a much better user experience to their users.
Great. What new business models do you see emerging from satellite broadcasters using DVB NIP? Rami, I'm going to ask this to you.
Sure. So as Laurent indicated, traditional broadcasting has primarily been focused on the delivery of video content to end users in their homes. And with DVB NIP, we're expanding the reach with kind of more seamless delivery to smart devices that go beyond just the TV. So the multi-screen aspect that Laurent just mentioned. But in reality, it also opens up the space for broadcasters to support additional use cases. And I'll talk a little bit about use cases here within the context of how it affects business models, because we can now expand that to not only support the end users in their homes, but it can actually expand to small and medium businesses as well. With native IP, you can have gateways that act as media hotspots on the reception side, and broadcasters can now sell a service to support these businesses by feeding these local hotspots with entertainment content that can be deployed to support a variety of use cases. For example, you can deploy a native IP hotspot in a hotel. Emily mentioned some of that earlier, to support the distribution of the hotel's entertainment library with high quality content that is either live or on demand, which is multicasted efficiently, and then ultimately reduces the burden of that hotel's network from an internet connectivity perspective. Another example of that can be a shopping mall that can deploy native IP hotspot kiosks, for example, where you can deploy content there, and the content can be purchased or rented and streamed directly to a end user's mobile device, from that hotspot. There are other examples of deploying this to maybe this content to public transportation stations, airports, other venues where you have people that are just waiting and might benefit from getting content. And native IP is a great way to deliver that, both for the private and government sector. I know I'm already mentioning a few of the use cases, but the point is that native IP is really broadening the scope and possibilities of the business models that broadcasters can now think of and benefit from. And it really opens the door for enhanced experiences, even for traditional DTH. And I'm sure that between Emily and Laurent, they'll talk a little bit more about how the enhancement of DTH is possible with native IP.
Okay, yeah. Go ahead.
The question of new business models is very important there, because this is what is also complex, because it's not only about feeding the end user directly, like DTH is about, but it's also about proposing new kind of services to any kind of small business, any place where, as you've mentioned, Rami, any place where people have to wait especially in low connected areas, you can provide a new service offering them live streaming at broadcast quality. And this is all the use cases that Rami mentioned. But this is new way of monetizing, because then you have to sell that solution to those small businesses. And this is also, by the way, why it was a second reason why it was difficult to deploy initially, so before the existence of that within DVB. It's because the satellite providers, so who offer the solution, has to adapt to the new to their new customers, you know, because they can reach, they have to promote that to the restaurants, to governments for installing this in hospitals, or in many places in Africa, they want to have this kind of service, for instance, so that people have entertainment for free instead of being aggressive together. So there are many use cases where this is thought for bringing either it can boost the competitivity of a company, like if we take a bus company in Latin America where they have a very long journey. They can offer that, so either for free or having they can monetize it. So it's either to boost the competitivity of those small businesses, or this can be also a service for governments to connect the people in low connectivity areas and so on. So that's how I think it's new. The model to sell it is new, and that should be, I mean, attention should be paid on that aspect.
Okay, and how else do you see DVB NIP changing the satellite broadcast landscape in the next 5 years? Emily?
So I think that first, the driving market for this is more in emerging markets, because today, so DTH is working, DTH is fine. So to deploy anything new, you always need to have a very good proposition or a good way to monetize it, because otherwise you will not roll out. You will not invest if you don't have a return on investment. So those specific new business, which I've mentioned and Rami also just before, are driving the market, because this is new business that the broadcasters can reach. So this is why I think that in the 5 next years, it will be more deployments in those emerging markets where there is a sense to have those services. In the longer term, of course, there is a huge interest for satellites. So when they would have already some services on there using native IP, then they will be able to smoothly transition towards a full native IP DTH, which is what they call DTH 2.0, which is very true, because then they have a single platform to target both the main screen at home and all the connected devices at home, because this is exactly the same content. And I think we should mention also very short technical parenthesis, that native IP, what is it in the end? It's the delivery of OTT formats over broadcast networks. So it only needs, so in order to broadcast adaptive bitrate formats, you need to have a flat bandwidth. So you only need to add a block, which is DVB NABR for multicast ABR. And that block is what makes the bitrate flat. And then you can send it over broadcast. And that's why at the receiving side, you will need a product. So we call it a native IP gateway. It can be based on a set-top box in terms of hardware. So you need that box on the end user side. So in the restaurant, hotel, or in the longer term for DTH 2.0 in the home. And that box will de-encapsulate. So it will just remove DVB NABR part, so that after the gateway, it's just OTT, regular OTT. It can be consumed by any receiver at home, any phone, any device. So in the future, I think that makes sense, of course, that there is only one type of formats delivered, either through IP and through broadcast.
Okay.
Yeah, I would add one point. There is another opportunity that is brought with native IP. It's worth to mention that native IP and integrating streaming technology in broadcast is not the it's not an initiative only from DVB. There are other standardization body that adopt the same strategy. ATSC3 for terrestrial, it's similar, and also 5G broadcast or the 3GPP has adapted the same kind of approach for the delivery of media content over mobile network, whether it's a multicast or 5G broadcast. And the thing is, so in fact, for the terrestrial delivery, you have the choice between these three standards: ATSC, DVB Native IP, and 5G broadcast. But for satellite, there is only a native IP that is adapted for satellite delivery. And the other point is that 5G broadcast and DVB Native IP are designed to work together. The fact that they are using the same multicast protocol, so it's easy to integrate content, native IP content delivered over broadcast into a 5G broadcast network. So they can be a complementary technology because they are relying on the same multicast protocol. So with the development of video services over 5G broadcast or 5G multicast, there are additional opportunities for satellite and native IP services.
Did we try to maximize the commonalities among the various standards, and in particular the 3GPP technologies, since we aim at be able to interwork with those delivery networks? Yeah.
Okay, Laurent, how simple or challenging is the migration from traditional broadcast, such as DVB-S2 to DVB NIP? And what are the biggest challenges, if any?
Yeah, so it's true that migration is not always easy. We've seen that to when we migrate from SD to HD. So it's a transition of technology. If you are launching a greenfield operation, I would say that native IP should be a no-brainer because it's you don't have to consider legacy, and it's a more modern stack that offers multiple possibilities. So, but it's true that for existing operation with a legacy in place, we have to be more cautious. So on the head-end side, it's quite simple because as we said, most of the broadcasters already have an OTT head-end, so they can reuse that one and integrate a new components or native IP server that will generate the multicast stream and the associated signalization to adapt the content to the satellite delivery. So that's something that will be in parallel of the multiplexer. It's quite it's a new component to integrate in the head-end. The part that will take more work would be to retrofit the existing and the legacy set-top boxes. And for that, it's not a matter of hardware or processing power, because native IP is not very demanding in terms of memory of processing power. But it's more to do the rework on the software side to integrate a multicast Ampere client that will be able to extract the streaming format and deliver it to the streaming player. So it's not very complex, but we work on the software of legacy devices. Sometimes not that easy, but if you have a control over the software of your set-top boxes, it's certainly feasible.
Rami, with the successful demonstrations and deployments like the one initiated by the government of Peru, what technical challenges still need to be addressed for full-scale commercial rollout?
I think that from a technical perspective, the native IP standard already solves the vast majority of requirements when it comes to full-scale commercial rollouts. Our deployment of native IP in Peru with our ecosystem partners such as EKT, Z Broadcast, and the others demonstrate that the ability for native IP to make a huge impact on connecting rural communities with critical news and entertainment content that's primarily been free to air So maybe perhaps one of the challenges that still remains to be kind of included as part of the framework is around content security and digital rights management, which is currently beyond the scope of the standard, but it's something that the DVB organization and project is looking to provide some help with. There are really two main challenges that come with securing content. I think the first is dependent on the deployment scenario, where connectivity is unidirectional and where you have no other means of connectivity available to you, which makes DRM a bit difficult to deploy and manage. But then the second one is really with regards to the requirements set by the content owner or the provider, because they will each have their own view on how content should be protected and what they would demand from a broadcaster to provide in order to meet the requirements. And that will change from one content owner to another. At iDirect, we've found a commercial solution to resolve the unidirectional scenario for DRM by partnering with one of the DRM leaders in that space. But it's still something that I think would benefit to be maybe added or supported a bit more through DVB NIP eventually. But otherwise, I would say that, the per use case is a validation of the technical specification of DVB NIP and its ability to roll out a robust solution.
Great. So moving on to use cases, which industry verticals such as maritime, aeronautics, hospitality, or distance learning are showing the most interest in DVB NIP? Emily?
So I heard so which one would come first? Distance learning is something that comes very often, speaking about native IP. If I can remember a story I was told in another corridor about, so I can't remember in which country, but you can guess, people having to go on a bicycle with a USB key to update the schools with a new program, So that still exists and could be avoided using DVB Native IP. Some of our members are developing, so based on native IP, they extend the service, providing a system where the teachers can prepare exams, or they can have the official program and prepare exams, and then the students are just answering the questions. So through this same, through the native IP gateway, you can do that. So you have access, so not only to live educational channels, but also to any kind of content, and because DVB Native IP can also deliver some data. So this use case is pretty much, driving the market. I would say there's such a demand in Morocco, Africa, South America also. There's been discussions about that. So distance learning is a strong one. And especially after COVID, by the way, it has been because people could not go to school anymore. So it was some of the former proprietary solutions were trying to indeed provide something. But yeah, it had to wait for the standardization. And
to complement, this kind of service is based on the fact that, in fact, with native IP, we are managing files. It's like streaming a small chunk of files, so we can deliver using this technology any type of file. So we can use it to deliver educational content that can be PDF or whatever in form of files, but it's also we can use it to deliver on-demand content and to deliver non-linear video service for operators. So more like a push VOD. So that's the kind of capacity that is easier to integrate and to deliver using native IP.
And indeed, so those use cases are very much discussed. However, thinking out loud, in the end, the first deployment is not about those new business models, but rather for DTH, like in Peru. So I think this is because it's much simpler to bring to the market in terms of business, because it's a business that people know already. Whereas the other one is more complex. You have to go to different people to promote your solution. So that's why the need seems to be stronger on those use cases. Use case of having a gateway feeding many devices in low connectivity areas, but this is much more difficult to bring to the market.
Yeah. I would also say that one of the advantages of distance learning is in a lot of cases, you have government institutions that are willing to fund these types of endeavors. So there is a financial backing to help support these kind of use cases, and it helps push things in the right direction. Of course, government projects do tend to take longer than other projects, but it is at least a financial incentive for companies that are interested in this kind of use case. We also, have seen use cases with regards to crew welfare that we have been involved in. We actually have an active proof of concept as we speak with Eutelsat and one of their maritime service providers in Germany, Media Mobile, where we've partnered with content and technology providers such as Airma and Inverdo for the delivery of welfare entertainment to the German tanker shipping crews. As in many industries, if you have a happy workforce that's motivated, it benefits the entire company and the delivery of services. And usually the investment that you make in crew welfare is at the top of any fleet operator's list of priorities. At least that's coming directly from companies like Media Mobile and what they tell us are the priorities for these kinds of companies. So beyond the technological aspect of the POC, we've also learned quite a bit about the use case requirements and the business model we would have to adopt to make this a successful service. For instance, we distributed a questionnaire to the German tanker shipping crews, and we gathered a lot of information on the type of content that's best suited for each individual vessel. And then we found out that, they have interest in news and sports, but also in content that is native to their own languages, because a lot of these vessels have crew members that come from various nationalities. And so it helped us shape the right bouquets that align with them. And with native IP, we're able to deliver these different bouquets very easily to different vessels. There was, on top of that, the educational aspect that Laurent and Emily mentioned, which was even to help with some of the maintenance aspects of a tanker ship that can be delivered through files with a native IP, because again, as Laurent mentioned, it's all ultimately IP data that's being delivered, whether it's video that's live, whether it's on-demand content, or it's actually files that you can send over. So there are definitely a lot of use cases across the board that are benefiting from the technology.
Question about government. Sorry, Laurent. Okay.
I wanted to mention another use case that we explored recently with Sky Italia. It's we use native IP for hospitality and hotel use case. So the need that they have is to equip each room of the hotel with a streaming device so that the visitors of the hotel can benefit from all the streaming experience with on-demand and catch up. But in fact, the connectivity of the hotel cannot support one single stream per room. So it's too much for the bandwidth and the connectivity of the hotel. And so what we've done using native IP is we bring the most popular channel through native IP to a local cache in the hotel. And then when a user selects one of these popular channels, it gets delivered through this local cache or through satellite and not through the broadband connection of the hotel. So that's why with this kind of approach, that can scale, and equip all the room of the hotel with a streaming box and offer this streaming experience. And so it shows really, and it's completely seamless for the end user. The end user doesn't know if a specific service is delivered through satellite or through broadband. So it's really show how you can blend and merge together broadband and broadcast delivery using native IP.
Okay.
It's funny to hear that this use case is something that was trying to be done nearly 10 years ago. That's with a proprietary solution. So if I may just add one, I think about speaking about the government-funded projects, it makes me think of an important discussion also, which is happening in India. So here there's a strong need, of course, to connect still thousands of people which are living in remote villages. I heard about 800,000 villages which are not connected. However, those villages have what they call community service centers, which are places where people can go and they have Wi-Fi, but strangely not enough for streaming. It's more for, I think it's for files, or I don't know exactly what they are using this for, but they have a Wi-Fi infrastructure in those small community service centers. And those would be the perfect places for a DVB native IP gateway. For instance, so you have the links already because you have DVB S2 links. So as Laurent said, it's very straightforward to upgrade a traditional broadcast link into a DVB native IP link. So what they would simply need to do is to add a DVB native IP gateway, so just one per village, then just reuse the Wi-Fi infrastructure, and then people simply have access to tens of live channels. So this is being discussed. Of course, it's complicated because it's a very highly competitive environment. So I think DVB native IP makes a lot of sense here, for instance, also for this use case.
You mentioned India. Are there other specific regions or markets where DVB NIP adoption is happening faster, and what's driving that demand? Rami?
Sure. I mean, I think Emily mentioned this as well earlier, which is about areas that have low connectivity. One example of this is one where we had a customer in Canada that was in a much, it's an isolated kind of environment in the region of Canada where satellite is the only means of communication. And it's a community similar to the one that Emily described there, where they have service centers, but also they have customers that are wealthy. So the financial aspect there isn't an issue. They're willing to upgrade their systems to brand new ones, but they're really hungry for connectivity and media consumptions. And in fact, this is an interesting use case because the customer was looking at native IP as a means to compete with a very popular LEO provider that a lot of people are seeing gaining a lot of traction in the world. And the idea was that they could use native IP to provide a dual play type of service that included media and video content that is localized and provided at a high quality alongside the data services that they would provide over geo, for instance. Because of the fact that, as Laurent mentioned, you have the efficiencies of multicast and being able to deliver content once at a very high quality to an infinite amount of receiving points, it provided a very attractive model for that service provider that would be competing against another service provider that is providing just raw data that might not be very optimized for high demand of IP traffic and especially video traffic that would have otherwise been initiated kind of in a unicast way and overloaded the network. So yeah, there are really a lot of use cases, but I think that the underconnected scenarios are one that are the most hungry for these types of technologies, and I think that's where we're seeing a lot of traction as well. Emily?
Yeah, in Africa, in addition. So where we hear the most about the native IP projects, it's Africa, especially South Africa. I think there are some trials. So South America, we've mentioned, so there is Peru, but the neighboring countries are, I think, looking at doing the same. So North America, you've mentioned, but it's also happening in Europe in the end. You see Sky Italia. And about Asian countries, I've heard about, yes, in Indonesia also there's been some trials. I don't know where it is now, but so I would say in the end it's more over, nearly everywhere, not only remote areas, but it's also in places in North America and Europe.
Okay. We have an audience question. Will CDNs still be necessary, and what differentiates DVB NIP from existing formats like LL, HLS, and Dash in terms of transmission and latency? Emily, do you want to take that?
Yeah, so of course CDNs will still be necessary. I don't see any, I see mainly a complementarity between the strengths of satellite networks and broadband ones, so of course. And the question about LL, HLS, so I suppose it's low latency HLS, and he mentioned also Dash. So DVB Native IP is actually based on those formats. So the specification of DVB Native IP specifies DVB Dash as the official streaming format. So DVB Dash it's building on Dash, however it brings, so it's profiling Dash actually. It brings some more interoperability and it brings also low latency. So it's a subset, I would say, of an optimized subset of Dash. So DVB Native IP is actually Dash somehow, on which you add, as Laurent also mentioned, that additional block, which I also mentioned before as DVB MEBR for multicast adaptive bitrate. So you bring that on top of either DVB Dash or HLS, and then this is modulated and then transmitted over either satellite like DVB S2 or S2X, or over terrestrial networks like DVB-T2.
And it's the fact that we are using, just to complement, it's the fact that we are using these protocols, HLS or Dash, that makes the compatibility with all the streaming device or the mobile device. So there is no question about that, because we are using these protocols that are well supported by this type of devices.
So Dash is the official one because the most optimized in terms of interoperability and low latency, but then the HLS is also possible, even if slightly not as standard as DVB Dash.
Yeah. And in the model that we are considering, in fact, CDN is working alongside the broadcast delivery, and it's the same content that goes over a CDN, maybe for if to be delivered on a part on an area where there is no satellite delivery or no gateway, and that goes for transmission over satellite. So say satellite is more considered as another CDN, another way to deliver your content to the end user, and it's the same interface somehow between the packager, the OTT packager, and the CDN and the broadcast network.
Yeah,
yes.
I mean it's helping expand the CDN network, right, in locations that wouldn't be otherwise accessible, other than satellite. So you can use satellite to deploy CDNs in locations that you aren't that aren't connected in any other means. So it's certainly a complement to that.
It's one more delivery networks actually for those OTT formats, HLS and Dash. You can send them over broadband, of course, but then with DVB Native IP, you have an extra possibility to also deliver them through satellite networks. And in the future, so I heard about people working on such a solution. In the future, you could ideally be able to switch between those delivery networks for an operator who has both access to both satellite and broadband. He could, for times where a service is very popular, highly demanded, you could then have it on satellite, whereas when it's not as much demanded, then it can be only available on IP, for instance.
Okay, and another question, how do you see native IP playing a role in the fast channels distribution?
Yeah, I mean, fast channels is just another mechanism to deliver a simulated live type of linear channel model. The idea is that you essentially can create a live looking channel with VOD content as well. So from a native IP distribution perspective, it's no different, because ultimately it's still data that we're able to deliver to the endpoints. And I'm sure Laurent has additional experience with that.
Yeah, we had some experience. In fact, we are not using native IP, but to take the most popular fast channel and to bring them over satellite to extend their reach and their audience, and we could do the same with using native IP for sure.
Yeah.
Okay, great. We have about 8 minutes left. As streaming continues to dominate, how does DVB NIP position satellite as a viable and competitive option for large-scale content distribution? Laurent?
Yeah, it's related to the discussion that we had just previously regarding the cohabitation of CDN and broadcast delivery. We see that even in the most developed countries, delivering large streaming event to a large-scale audience remains a challenge. We see Netflix with NFL game during Christmas. It's really remain challenging. So you can imagine for other content provider and other area, it's even more so. Yeah, really satellite delivery remain really the most efficient way of delivering this kind of event at a large scale and to the whole population. It really brings the reach. So what we bring with NIP is that we offer this type of possibility to deliver this content at scale and anywhere in the coverage area, while remaining in the streaming ecosystem. So you don't have to, if you are a streaming native player, streaming native service, you don't have to change everything to deliver a broadcast service. You can stay with your current application, your current way of managing the content, of evaluating the audience, of inserting ads while delivering the content over broadcast. So it's really enabled this content provider to add a broadcast leg to their distribution strategy, so that they are sure that they can scale and deliver this kind of content with a large audience with a good quality of service.
Okay, and what steps should satellite service providers take today to prepare for the widespread adoption of DVB NIP? Rami?
Yeah, I mean, I'll kick it off, and Laurent will obviously add some more there. But I think, from our perspective at iDirect, we believe that the lines between kind of the data world and the video world are increasingly getting blurred. We just talked about streaming, right? And it's our mission really to make sure that we help traditional broadcasters and traditional satellite data providers alike to bridge the gap between these two worlds. And we can do that with native IP. With native IP, we have a way to guide both sides of the industry towards a kind of a collaborative way for delivery of content in a way that is applicable to real world scenarios and is profitable. So from our perspective, our recommendation is for service providers to reach out to companies like ours and other DVB NIP experts to see how we can support them in the many use cases that we just talked about and that are possible with native IP. And again, it's, obviously it's not a new concept. As Emily discussed, this has been something that we have been talking in the industry about for a very long time, but we now have the framework that allows us to do this in a more open way and hopefully in a collaborative way that benefits everyone. So we're quite excited to be part of it and really happy to be working with the rest of the members in the DVB NIP team.
Hey, Laurent?
Yeah, I would just add that, we have a community working on native IP. We have several technology vendors, so I engage with a satellite service provider to engage with this technology provider so that they can see the variety and the diversity of offer and see also the maturity of the solution. And so we have several technology vendors that have developed products and solutions that are compatible and that are compliant with the standards. So discuss with them, discuss the use case, experiment the technology, and then you should integrate this kind of approach in your technology roadmap.
Emily, anything to add to that?
I think they answered very well that question. Yeah.
Well, the last question is for you. Will DVB NIP allow satellite broadcasters to compete directly with terrestrial broadband and fiber, or is it more of a complementary technology?
It's definitely a complementary. I don't really like the word competing because I think they are very, they have complementing strengths. So not only for resilience, of course, is something very important. We don't want to put all our eggs in the same basket, but I think there are even much more, there are promising scenario where you can see very nice complementarity. For instance, coming back on the example of India with those community service centers, for instance, if you combine DVB Native IP with DVB-I, which we haven't discussed yet, but DVB-I is one of the flagship solution in DVB currently. Just for you to know, it's a service layer, so it's not another delivery network. It's how to discover services that come from any network, actually, even not only DVB ones. So combined with DVB-I, DVB Native IP allows to bridge somehow satellite with 3GPP networks, because, for instance, you could have native IP gateways in those community service centers, so providing indoor reception. And then you could have those 5G towers. So that could be 5G broadcast towers, so UHF, as we know, or simply just the cellular networks, 5G, a new radio, and you could roll out progressively. And then, thanks to DVB-I, the end user would not have to know whether the service comes from satellite or from the outside from cellular. It will automatically switch from the native IP reception indoor to the cellular networks or 5G broadcast networks outdoors. So this gives the opportunity for 5G networks to progressively roll out, and then the DVB Native IP can answer right now to the need, which is to connect those people. And that works today with those legacy devices, because any device that has Wi-Fi, so now I think it's the case everywhere. So those devices are compatible with DVB Native IP. So this is very nice complementarity, and even more importantly, so those countries are discussing 5G broadcast, as you've heard, I think. So 5G broadcast can be, so it's a new DTT broadcast standard. So it still has some things to improve. And when speaking about indoor reception, there are still some, I would say, some issues which would then, you would need to have a very huge amount of towers to cover an area if you also wanted to cover indoor. So by providing indoor reception, thanks to DVB Native IP, you could drastically reduce the number of towers that you would need. So you simply remove indoor in your 5G link budgets. So that's, I think it's a very promising use case where networks are complementing and they are used for their own strengths. And there are other ones, of course, but we don't have time, I think.
All right, great. Well, we're at the end of the hour, so I'd like to take a moment to thank our panelists. If you're a WTA member, you can download the report free of charge from the WTA site. Coming up in April, we'll be at NAB. If you are attending NAB, please visit Eutelsat and ST Engineering iDirect in the West Hall. We'll also be at CABSAT. Upcoming reports, we have tomorrow's business model from Teleport to Network Services coming out in June. And in September, we'll have cyber threats in your own backyard. Again, thank you to all our panelists.
Thank you very much.
Thank you. Thank you, bye-bye.
Bye-bye.